Hello, dear students. We are studying the intext questions for group 16 elements and their periodic properties. We have studied about the fluorides or halides. The next question that we need to study is list the important sources of sulfur. Sulfur is found in free state in nature, and this free sulfur is generally found around the volcanoes, and this free sulfur is extracted or is taken out from the earth's surface by the process which is known as the frost process. In combined state, sulfur is found as sulfates like gypsum, which is calcium sulfate, and 2H2O, so hydrated calcium sulfate, Epsom salt, which is magnesium sulfate hydrated, that is MgSO4 into 7H2O. We have barite, that is BaSO4. Sulfur is also found into the sulfides as galena, that is PbS, zinc blende, that is ZnS, or copper pyrides, that is CuFeS2. Sulfur is also found into the hydrogen sulfide H2S gas, which is produced during the volcanic eruptions. Organic materials such as egg, hair, protein, garlic, onion, mustard, and wool, they possess sulfur or they contain sulfur. The next question. Write the order of thermal stability of the hydrides of group 16 elements. Thermal stability depends upon the bond dissociation enthalpy, and bond dissociation enthalpy decreases going down the group, so the order of thermal stability also decreases. Order of thermal stability for hydrides of group 16 can be written as H2O is greater than H2S is greater than H2Se is greater than H2Te is greater than H2PO. Now the next question. The question is, why H2O a liquid and H2S a gas? Due to high electronegativity of oxygen and fluorine and nitrogen, and rarely H bond is observed in compounds of carbon. So due to high electronegativity, oxygen, fluorine and nitrogen forms hydrogen bonding or H bonds. Thus, as oxygen present in H2O, it makes hydrogen bond. So hydrogen bonding increase the boiling point of water, but no hydrogen bond in H2S is possible. So lower boiling point for H2S. So boiling point of water is 100 degrees centigrade, while boiling point of H2S is minus 60 degrees centigrade, that is 213 Kelvin. So at room temperature, water is a liquid but H2S is a gas. My dear students, here for your reference, I have concluded about the halides, their formula, their shape. My dear students, please mind it well that we have written here the shape, not their geometry, because geometry is writing the lone pair and bond pair together, and shape explains only the bond pair, not the lone pair. So please mind it well. And I have also mentioned the type of hybridization that takes place into a particular halide. So let us study this one by one. First we will study about the hexahalides. These hexahalides may have the general formula EX6. The shape is octahedral and the hybridization is sp3d2 hybridization. Then we have tetrahalides. These tetrahalides are explained as EX4. They have seesaw structure and they have sp3 dehybridization. Actually, sp3 dehybridization is trigonal bipyramidal, but one of the equatorial position is taken by the lone pair, and that is how the shape turns as a seesaw. Dihalides are represented as EX2. Actually, they have sp3 hybridization, so they should have the tetrahedral geometry, but two position has taken by the lone pair, and that is why they have bent structure. Monohalide actually do not, they should be linear, but monohalides actually dimerizes. When they dimerizes, each sulfur or each oxygen or each element of group 16 present into them have sp3 hybridization, and they have open book shape of structures that I have already explained. I hope, my dear students, you are enjoying your studies. Happy learning.